Welcome to my GIS class. Today we have a closer look at projections that are used in Alberta. When we zoom into Alberta, we can see that it's covered by UTM zone 11 and 12. So we only have to deal with two UTM zones, but we cannot use either of them to display the entirety of Alberta. Let's quickly zoom into zone 11 to look at some details. So I change my projection right now to UTM zone 11. Now the center meridian is displayed perfectly from south to north, and we have symmetry on either side of the edges of the UTM zone. And I have my display in meters, and you can see that the center meridian has a value of about 500,000 east. So that's our forced easting. So our meridian has a value of 500,000. If we go east, the values are increasing up to around a little bit over 700,000. And if we go west to the edge, to the next UTM zone, there the lowest value is just under 300,000. So that means, of course, we only have to deal with positive values, and from around 300,000 to around 700,000 is our regular range. This range of easting values is, of course, the largest at the equator. Here we see that the values range from about minus 170,000 west and about plus 830,000 east. If we zoom into Lethbridge, Alberta, and I hover my mouse into the center, we can see that the distance to the equator is about 5.5 million meters or 5,500 kilometers. And the easting value in this case here is about 800,000 meters. That is something that should not occur in our latitudes. Currently, Lethbridge is projected in UTM zone 11. That is something we should never do. Lethbridge should either be displayed in UTM zone 12 or a specialized City of Lethbridge projection, which I will discuss later. Let's change the UTM zone to 12. I choose a layer in the correct UTM zone 12 projection. Now we see it has just changed slightly. It's leaning in a slightly different direction. And now if I hover into the center of Lethbridge, the distance to the equator has not changed, but our easting value now is in the expected range of UTM easting values. Let's go back and display Alberta. So it's very clear that we cannot use UTM zones to display the entirety of Alberta and make Alberta stand perfectly upright. Therefore, the province of Alberta has defined its own Alberta projection. And that is really just a small change in parameters of existing UTM projection. We can go to any UTM projection and we can change the parameters, and you can make your own projection by right-clicking and saying copy and modify. And now all the projection parameters are for edits. I don't want to touch the forwards easting. I don't want to touch the forwards northing. The only thing I want to do is put the center meridian into the center of Alberta. Alberta goes from minus 110 degrees west to minus 120 degrees west. So the center is minus 115. And because now, instead of being 6 degrees wide, we are going to be 10 degrees wide. Therefore, we have to change our scale factor slightly to account for the distortion as we go away from the center meridian. And I give this now also a name here. I call this 10 TM projection. And I hit save. And I hit OK. And now we see here the central meridian for Alberta is here. And let me turn off my UTM zones and the respective central meridians. Here now is minus 115 degrees west, and it's the central meridian for Alberta, and Alberta is upright. This is the only correct projection that we should ever use to display the entire province of Alberta. And then we have to consider special cases, and one special case is the city of Calgary. Calgary is divided by 2 UTM zones, and therefore it had to define its own projection so that city planners would have the accuracy that they need for the city planning layers. The city of Calgary, as we can see here, is right at the dividing meridian between UTM zone 12 and UTM zone 11, which is minus 114. So for Calgary, the projection is a specialized one where we go to a projection, we hit again copy and modify, and now for Calgary, I'm not going to execute this now, for Calgary we would just simply change this value to minus 114, and because it doesn't have to have the full range of 10 degrees for 10 TM or 6 degrees for UTM, we only actually go 3 degrees wide, and therefore we can increase our scale factor. The distortions are smaller, and these are the values that the city of Calgary uses. So I could call this now Calgary projection, and I could save this now. I also want to mention to you that Lethbridge has its own projection. It is identical to Calgary's projection. They adopted that. However, instead of using a false easting of 500,000, Lethbridge uses a false easting of 0, because we don't have to deal with negative values and the city extent is not very large, so we get away with this. The only problem with that is that it is breaking the convention that UTM zone-based projections always have a false easting of 500,000. The last comment I want to make is, once you have created your own projection, you have not really saved the projection. You want to basically take the projection that you have created. In my case here, this 10 TM projection that we just created a minute ago, there now, if you want to make it permanent, you have to right click and say add to favorites, which is something I have already done here. That way that projection is available for other projects. So please remember, the projections used for Alberta are 10 TM for the whole province. If you work on the western part, you can use UTM zone 11. If you work in the eastern part, you can work on UTM zone 12. Or if you work for the cities of Calgary or Lethbridge, you have to consider the specialized projections that were developed for those locations. When I have to prepare a study area map for an international audience, I like to add a map of where Alberta is relative to the rest of the world, because many people wouldn't know the details of Canadian provinces. So here on this display I have already Alberta highlighted, and I don't like the shape of Alberta how it is in this map, and I just don't want to use a regular Canadian projection because it wouldn't show the rest of the world. So in this case, what I like to do is I like to use a very specialized projection. It is called the world from space. To see the projection properties, we double click on our map. And before we go to the world from space. I want to point this part out. Right now we have the normal GCS WGS 1984 Geographic Coordinate System, World Geodetic System from 1984. And you will see here at the bottom there is a box, Enable Wrapping Around the Dateline. Let's just quickly see what that does. So at the moment it's turned off, and we can zoom in and out of this map, and we cannot do much more. And of course the center here is Greenwich, and then we have our dateline on the west and our dateline on the east, but we cannot wrap them around. We can enable that. Let's go back, double click. I enable the wraparound, and now we can wrap around the world and we can see it in different ways. So now we can do a Pacific centered map, or we can do a European centered map, or a North American centered map. So please keep that in mind, that option. Let's turn this off again right now, and let's go to the world from space. We find that under Projected Coordinate Systems, under World, and then near the bottom we see the world from space, and let's just say OK. Use the default lat long. And so here you see the world from space. Now we have a better sense of where Alberta is because the shape is preserved. And of course now we can change our view to any lat long combination that we want. Let's make it Alberta centered. So I go back. And in order to make a new projection, we simply right-click on the projection basis that we want and then modify. And the center for Alberta would be -115. And it's around, well, we can make it 55.5 to be exact. And say save. And there is our Alberta centered view from space. And we could use this, for instance, for making a map of where Alberta is relative to North America. Or we can also change it to any other location. Let's change it to this one here. And there would be a different view now, seeing the size and the location of Alberta relative to European countries and some African countries. So if you were to go, for instance, to a European conference, you may want to use a map like this. So please remember, the world from space offers you a view from any angle onto the globe, and you can drape any layers, of course, that you have onto this globe. That's all for now. I'll see you next time.